It was cut a little short, but let's continue. We're left with the explanation of the role of glycogenolysis and fermentation with regards to affecting the number of ATPs produced. In glycogenolysis, or the breakdown of glycogen, we know that glycogen is a polymer of many glucose molecules. What happens is that glycogen, upon the action of a phosphatase, would give rise to glucose 1-phosphate, alright, not 6-phosphate. But eventually, it will also be converted to the same glucose 6-phosphate. And this is very important because if you get your glucose 6-phosphate from glycogen and not from glucose, what happens is, look at this. Step number 1 is conversion of glucose to glucose 6-phosphate at the expense of 1 ATP. You used 1 ATP if you started with glucose, but if you started with glycogen, you will not consume ATP. So here, you actually conserve 1 ATP. And that's the only difference between starting off with glycogen and starting off with glucose, 1 ATP. But then again, of course, we know that glycogen is composed of many glucose units. So that's a lot of ATP. Now in fermentation, we know that instead of producing the reduced NADH, we actually use the reduced NADH. So instead of producing energy, we use energy. So here, we use 1 NADH, which is converted to usage of 2.5 ATP for every pyruvic acid that ferments to either ethanol or lactate. And that's a big turnaround because if the pyruvic acid turned into acetyl coenzyme A, it would instead be plus 2.5 ATP because in the conversion of pyruvate to acetyl coenzyme A, this is PTCA, you produce 2.5. So imagine from plus 2.5 in fermentation, you get minus 2.5. That's a 5 ATP swing. So that's the effect of fermentation and glycogenolysis in a nutshell on the ATP count.